rural area and small area students, mostly rural area students, right? So I'm also part of Hyderabad Python community group. So where I also speak on their meetup group and also co-organize, interact with folks who are industry experts, and then organize the events at meetup.com, mostly related to Python and data science. So the agenda is simple. So we understand what data science is all about, and then understand this is one biggest confusion, right? So difference between AI, machine learning, deep learning, data science. So some overview I'll give on that. And there are various roadmaps, and data science being there's no a fixed or a standard template to learn data science. People follow various roadmaps. So I'll show you a couple of them, and then also show you what we within Genpact, we have a team of 100 folks, and then we hire freshers. Whenever we hire freshers, we offer like an internship program. We have a collaboration with BITS as well, NIITs, IITs. So what we do is we have our own roadmaps designed. Every 6 months, we have around 15 to 20 interns, and then out of 15 to 20, so we again offer a full-time role for 5 to 6 folks. So it's been 4 or 5 years that we applied the various roadmaps, and then our own roadmap. I'll show you our own roadmap, what we apply within our Genpact, and then what are the essential skills which are required to become a data scientist, and the resources to learn. Well, there are many resources. Data science being very fancy, and many people follow this. Most of the people, they want to become a data scientist, but they give up in middle. Most of the people, my friends, especially my friends, what I have seen them, so they give up because of many factors. So quick resources from where to they learn. Again, there is always a confusion between data scientist, machine learning engineer, MLOps engineer, data analyst, business analyst. There's always a confusion what role, what to apply. Yeah, again, there will be a question answer sessions. So let's go. So data science, first of all, data science is not a new term. The kind of work what we do in data science is not new. The term is new, although it is been introduced maybe more than a decade ago. But the work what we do, basically it's like an information extraction, right? So you have a bunch of data set. So you extract some information from that raw data to make a better decision, right? So leadership team like CAOs, CFOs, chief technology officer, any of the leadership team, the AVPs, what they do is they take business decisions. On what basis they take a business decisions? Based on the data set, right? Based on the what past data has told us. So it's basically techniques. There are a bunch of techniques, analytical techniques, and some sort of a scientific approach um, to extract some valuable information from the data set. So why do we extract? To make better decisions, right? To plan the future. There are many things, and it's not a fix. Again, there is no fixed definition. What exactly data science? People coin in different forms, but in summary, you have a data set. You derive meaningful information from the data set. Why do derive? To make better decisions, future decisions, to plan your future, right? So your company's organization future. So there's always a confusion between many folks who are willing to go into data science, who are willing to become, who are planning to get into this field. There's always a confusion between what exactly artificial intelligence is, what exactly machine learning is, uh, how they overlap each other. So there is always a confusion. So as mentioned before, the kind of work what we do in data science is not new. It's been there for decades. My manager's manager, so he used to do data science what we do here around 20 years ago. So in Microsoft Excel. So the core areas, what you see in the right hand side, so mathematics, statistics, data visualization, exploratory data analysis, mostly these kind of work, data visualization, creating reports, building dashboards, especially using Excel, and understanding the data, drawing basically descriptive statistics, right? Kind of having a descriptive statistics, or in fact inferential statistics based on the inferences, based on the data set what we have, sample data set. They used to derive inferences, and we still do that, inferences, derive and future inferences, right, by using a sample data set. So these things were already there. These understanding mathematics, statistics, data visualization, exploratory data analysis, especially using Excel, SAS, Power BI. These tools were already there. Especially SAS was one of the biggest tool which was used 20 years. It's been used in the many industries, especially the banking. So these things were already there. Data science, the term which is being introduced, right, a decade ago, more than a decade ago. So it is a kind of an intersection of some of the techniques of deep learning, some of the techniques of machine learning, some of the techniques of artificial intelligence. So it's like a mix. So it's not a what you call, it's not a fixed bunch of techniques. It's a mix of many things. It's an intersection of many things. But in summary, so data scientist is someone who understands maths well, who understands statistics well, who understands data well, data understanding well, who understands how to wrangle around the data set, how to derive some insights from the data sets is all about, who has some very good analytical skills. So this he is called mostly the data scientist. But again, each organization has their own product-based companies, big giants like Microsoft, Google, Amazon, especially Amazon has a separate role. They'll not give data scientist to a person who's a fresher and who is actually has a computer science background. They might prefer to give data scientist designation for a fresher who has done a specialization or who has done a PhD or master in the areas of mathematics, in the area of data scientist. So company to company, organization to organization, it differs. They have a separate role for specialization. There is a separate role for deep learning. Then there's a separate role for machine learning engineer. There's a separate role for AI engineer in big companies. But in startups and all, so only one person does all of these work. But it won't happen overnight. Nobody becomes data scientist overnight. It takes ample enough time to achieve that, and there is no end to it, and there is always an evolution. There is always a learning. However, there are few foundational knowledge, essential knowledge, which is required to become a data scientist. So I'll walk you through some of those techniques. So this is what I just want to tell. So this is not a new data science. The name might be fancy, but this is not a new technique. It's just a name is being given something like a data science, which looks fancy. But the kind of work what we do, except these AI, machine learning, deep learning, these things are getting evolved, and these things are getting famous in last decade. But the kind of work people are doing in data science work, it's been there for decades. So yeah, this is what I would say. It's like an intersection of many things. So you need to understand some of the fundamentals and some of the. It's okay if you don't know deep learning, but some of the machine learning algorithms you need to know to become a good data scientist. So one of the roadmap is this is good, and it takes a lot of time to become a roadmap. This is one of the techniques. There are many techniques. You learn some sort of applied maths and statistics. I'm sure you are already doing in your current education where you are pursuing your education. So there are specialization again in mathematics. You learn if you already have the knowledge. You save this some time here. All you have to do is refresh some of the basics, those skills. This is the first step, and the second step is you learn programming, Python. I'm sure you being a bits guy, so obviously you do many competitive programming. So you use C, Java, but in data scientist we prefer Python. Python is a dominant language in data science. So if you are already doing coding, if you are already doing competitive programming, so practice using Python, HackerRank, LeetCode, any of the problems problems what you're solving. So practice using use a programming language as Python, because it becomes easier if you're aiming to become data scientist. Again, the principles are same. Even if you are practicing C, C++, the core principles, the algorithms remain same, the approach remains same, but just the syntax will differ. But it becomes easier if you know before itself. Then you go to data collection. How do you collect the data? You learn some sort of a data scraping techniques and the many techniques and data wrangling, and do some sort of a data engineering. You learn some sort of a SQL data engineering, some sort of a coding. And again, you do core EDA to understand the data, one variable versus another. You check in categorical variables, you check numerical variable, you check how they are correlated with the label. So this is a step you apply. Once you understand this, then you learn about machine learning. Then you learn each and every algorithm, linear regression, logistic regression. Then deep learning. Then you actually, after doing all of these activities, right, then you start actually solving a problem. So if you have a software engineering background, you might know the terminologies like a waterfall model. Like there are various standards, right, in software engineering practices, right? So waterfall model, agile model, software life cycle, software engineering life cycle, or software development life cycle. It's like a waterfall model, right? So you don't you don't by learning programming, simple programming, you don't directly try doing developing a complex projects. You complete each and every step before, like sequentially. You complete one step, and then must proceed to second. This is one of the roadmaps, and there are many roadmaps. And believe me, it takes a lot of time, and people lose their motivation, putting 24 to 26 weeks, and then you literally lose your patience. You will be to become a data scientist using this approach. You have to be self-driven. So you need to be self-motivated. It takes a lot with the current buzzes around, current disturbance around. It is very difficult, nearly impossible to become a data scientist using this approach. Well, there are people. I'm not saying that this is a wrong approach. If you are focused, self-driven, then obviously you can. And this is the best approach, one of the best approach, and you become a strong in foundationally, and then you try to solve a complex problem. This is good, and people follow this. I don't deny, but whatever I have seen from my experience, this fails majority of the time. The other approach I have is here. This is again from Analytics Vidya. I'm sure you know this Analytics Vidya. So again, it takes 1 year. This was a 2021 plan. And you start in January. You understand what data science is all about. You understand Python. You understand NumPy, Pandas. This is in January. Again, in February you do data visualization. In March you do data exploration, and then in April again you do a machine learning. You learn each and every algorithms, and then you do many things. And again, it takes one year, and then to come to projects and applying for the jobs. So 1 year is again, in 1 year there are many versions. There are every day. It's like a changing industry, right? It's a very dynamic industry. Data science is very dynamic industry. So not only data science, in fact, the software IT companies or the software industry itself is very dynamic in nature. So again, the problem is you lose motivation, you lose focus if you follow the approach by spending months or a year of your effort in reading and applying for the project, right? So obviously there are problems, right? There are many problems. So as I told, you'll not be. You have to be a self-driven, and you lose the focus. and people, friends around you, they do many, like some of them they do full stack, some of them they do merge stack, some of them they go in many other areas, right? So it looks fancy. They start developing Android apps. They start in 1 month or 2 months, you'll see they if there is a full stack developer, he starts having his own website, he starts developing, learning many things and start developing applications. If there is a full stack a developer who's your friend, right? So you'll be frustrated. So obviously 1 year of effort, you're putting, and then surrounded by people like a full stack guy, so you'll definitely lose focus, and then you derail yourself, and you yourself move towards a software engineer or a full stack role. I'm not saying that software engineer or full stack role is wrong, or they don't pay you more. Of course, it's also one of the best jobs to do. But if you want to become a data scientist, yeah, so this approach is the traditional approach, the approach, what roadmap, what we have seen. So yeah, again, there are various roadmaps. People follow various roadmaps. Again, you will get confused in that. I'll tell something. Analytics India, Analytics Vidya is telling you something, and there are other companies are selling, other communities are telling something. There are many approach. You get lost. This way is right, that way is right. Obviously, you will be lost, and you can't read all of this, right? In 1 year or 6 months or 4 months, it becomes very difficult. You start skipping, and then you start demoting, and then you can't read all of these in less time. So yeah, obviously, what would I suggest? What is that? Which I mean, from my experience, I've been leading a team. I also lead a mentorship program in Genpact. So I educate people. I onboard interns, Bits guys, Bits Goa, Bits Plani, Hyderabad. So we have a tie-up with them. So this is my experience, our Genpact experience with along with my few colleagues. So the approach is very simple. So you need to learn the basics of Python, basics of Pandas. What are those? Just basics. You don't have to become expert. All you have to do is learn the have the elementary knowledge, basic knowledge about Python, basics Python. You should know how to write a for loop. You should know how to write a dictionary set, which you do it obviously when you study C++. That level of basic knowledge is required for programming. You just need to know some of the libraries like Pandas, NumPy, scikit-learn, some of the basics of those libraries, how to read the data set, how to train the data, how to train a model, basic knowledge. Then start building your projects. So with the basic knowledge, take some sample data set, start building the projects instead of learning each and every step, going in detail of those terminologies, like becoming let's say Pandas or maybe NumPy. You don't have to go in detail of that library. All you have to do is whatever is required for a moment, on fly, you learn the basics and then start building projects right from the day one, right? When you learn basics, start building the projects, start solving problems, do some research, and start building projects, and start sharing your work, right? Upload all your work in GitHub. There are platforms like Kaggle. There are platforms. There are various analytics. Vidya, they have the hackathons. Start sharing your work on LinkedIn. So learn from others. Like when you have I'll tell you some of the platforms. Like Kaggle is one of the very famous platforms. So learn from others. You actually, when you start sharing your work, you actually get to interact with various folks, ask questions, post your questions, even if it is a basic question, even if it is already answered. Start asking the questions, right? Start posting the questions on those platforms. Even if it is simple linear regression, even if it is a simple logistic regression you don't know. So start posting those and learn from others. There are many folks, right? You'll find people like you who are also trying to learn. So form a team of folks, and then spend time, and then start sharing your work, and also try to find a mentor, right? So when you have a team, when you join communities like DPhi, join communities, and various other platforms are there. So learn from them. Approach people like me. They approach people like who are part of our team. So through LinkedIn, through Kaggle, through many other platforms. Learn from them. Learn from their experiences. Right. So example, if I take if you are reading a book or a famous author book or famous personality book, so why do you read? So basically, you don't make the mistakes what the person who the author has made, right? So you learn from him. Similarly, there are data scientists. There are a bunch of data scientists. They have put their knowledge, they have put their learnings in the form of books, in the form of their blogs. So learn from them, follow them, learn from them. So this is what's simple. It's very simple. Learn the basics, build projects, share your work on LinkedIn, share your work on GitHub, share your work on Kaggle, and there are various other platforms, and then learn from others. So this is simple. So I mean, I'm sure you must be very happy. Okay, so you can become a data scientist, and the approach is very, very simple, and there are only 4-5 steps. Okay, hold on. Ruko thodi der. It's not that simple though. So what are the crucial skills which are required? First one is Python. Don't derail yourself. Don't debate yourself. Java versus Python versus R. Mostly Python versus R. Don't get into that kind of debate. Only one language which is being used now is Python. If you want to become a data scientist, the dominant language. There are people who are still using SAS. There are people who are still using Excel to build some sort of data science work. There are still people who are using R. I'll not go into that debate, but focus on one programming language instead of focusing on the debate. Python, basics of Python is enough. You don't have to become a Python developer. You don't have to learn to become a Python developer. Learn Python to become a Python developer, a software engineer. So only essential Python, basics of Python is required. For example, basics of data types, looping, functions, dictionary, list, tuple. So they're only basics. Only basics. You can do it in one day. The learning of Python. Understand some of the libraries. Pandas. You don't have to go in detail of pandas. You don't have to go in detail of Sybon. You don't have to go in detail of NumPy. And only to get started, only these libraries are enough. Pandas, Sybon, NumPy, NumPy or NumPy or scikit-learn. This is enough. All you have to do is, you don't have to go in detail of those. All you have to do is understand how to use them, how to use those libraries for your data set. And there are algorithms, machine learning, deep learning. These are more than enough. This is not an exhaustive list, but I would say these are more than enough. Even if you take one algorithm a day, for example, let's say linear regression, learn these things in low time, as fast as possible, and take one algorithm. Example like a linear regression. Understand what is a linear algebra behind that linear regression. Understand what is the statistics behind that linear regression. Understand what is the calculus behind that linear regression. That's enough. Linear algebra itself is a very big topic, and people do specialization in that topic itself. Statistics itself is a big topic, and then people do again a specialization in that area. Calculus itself is a big topic in mathematics, right? So again, people do specialization in that area. So you don't have to become an expert in all of these areas, and you don't have to. You hardly derive or customize the rules. So all you have to do is understand how linear regression works, what linear regression is, only one algorithm at a time. Understand the linear algebra behind it, and it's very, very simple. Equation of a straight line, what exactly polynomial equation is all about. Understand the basic statistics and understand the calculus, basic derivatives. That's all. Chain rules. Some of the calculus rules are there, derivative rules, and how to derive slope on the graph, which is not a linear, non-linear graph. So only derivatives, few derivatives. Like you don't have to go to again in calculus. You don't have to learn integration part. Only few partial derivatives concepts you need to have. I'll tell you what all those. These are all enough. If you complete this one linear regression, understood one linear regression, then look for the projects. Do projects on linear regression. Do real-time projects. From where do you get the data set? Where do where do you get the real-time projects, where do you get the real-time data. I'll show you in further slides. Concept is very simple. Learn pandas, learn Python, learn these libraries. Again, you don't have to become expert. Only essential part. Choose one algorithm at a time. Only one algorithm at a time, and then learn maths behind it, and switch to next algorithm. Here, if you learn linear regression, some part of the linear algebra, some part of the statistics, some part of the calculus is already being used here. And there will be some extra stuff like you in logistic regression. There are concepts like probability. Logistic regression, you have concepts like logarithms, logs, odds, right? So some of the extra terminologies are there in logistic regression. You learn. Obviously, you have to improvise, and then once you learn the linear algebra, statistics, and calculus, which are required in or maybe for the matter of whichever is required for logistic regression, learn that, and then apply that logistic regression on some other data set. So, and then move on to disjointry. Again, disjointry, you have some sort of a concept of entropies, uncertainties, and then there is something like that. There are many various other techniques, and then move on to supported machine and move on. So this is what is required to become a data scientist, right? So these are the core. You don't have to be distracted by doing many things. So choose one algorithm. Even if you spend 1 week for one algorithm, I'll say 1 or 2 days is enough. Even if you spend 1 week, but still you would be able to become a very good data scientist in no time, in few months itself. You don't have to spend year to become a good data scientist. So that's enough. So, and then again, each time when you do, each time when you learn, right? So you improvise, try to learn. You start reading the data from a CSV. Next time you start reading the data from database, understand SQL. Next time you try to push your code to a GitHub, have a good GitHub profile. These are very, very important skills to become. Again, these are very, very important, and these, even if you don't have, it's fine. Yeah, communication skills, obviously, you being from a very good college, you will certainly have a good communication skills. But people, introvert kind of people, they don't have, even if they have, they don't come out easily, right? So you have to come out, you have to start writing, you have to asking the people, like you have to become extrovert person. So this is one of the skills. These are the crucial skills. Nothing fancy, nothing more. It's very, very simple applied approach which we use in our team. I'll tell you what exactly, how much time does it take, and how we derive. Again, if we go to essential linear algebra, so I've told linear algebra, statistics, and all, right. Linear algebra itself is a very big topic. In that, what exactly you need? These are very, very basic. Some people with a very good syllabus, they I'm sure they must have studied all of these things in their high school itself. These essential algebra. So some sort of functions. Again, there are various functions. You need to understand only few to start with. I'm sure most of you already know. Matrix तो आता ही है सबको. Some sort of a linear transformations. This is enough to get started. And this is not a exhaustive list to become expert in data scientist. To get started, this is more than enough. And statistics, this is more than enough. Understand what exactly data is, and we already know many of these things. The problem with the traditional approach, what I've showed in the beginning roadmap 1-2, is many of the things you already know, and then you try to become expert in that area, which is not required. You already know most of you already know what exactly standard deviation is. Most of you already know what variance is. Now, the objective is you have to correlate how standard deviation can be used in linear regression, how variance is getting used in linear regression, right? How correlation, covariance, how that they are getting used in, maybe let's say, principal component analysis algorithms. These things are important. That's all. These these are hypothesis testing. These are again are required, but you don't have to become expert. And these things, I'm telling you, if you spend 4 to 5 hours a day, right, in linear algebra, I'm sure you already know most of these, but you can finish it in one day by writing. And this can be finished maybe in 2 days or 3 days or maybe 1 week, even if you go separately. And this can be by watching some of the videos, YouTube videos. You can easily learn. We already know all of these. Partial derivatives means what? Great and decent. Maybe it is a little complex. Some of the partial derivatives, maybe it is little complex. But yeah, some of these terminologies we already know. Yeah, so this is what we have in our team. This is what we apply, and this has been being very successful within our team. I'll show you some of the proofs also. Not blindly saying this. So we have teams. We have a team of 100 people, and then we have a minimum 15 to 20 interns each batch every 6 months, and we segregate the teams. Like we form a team who are working purely on structured data, and then we offer internship to students, right? So it's like a 6-month internship. So if I go by the traditional approach, it takes 1 year, but what is the ask for the interns is they have to learn everything in 6 months. They have to also do real-time projects. Whatever they learn, they have to apply their learning in real-time projects. They'll not be given to client data set, but they will be given a synthetic data which is like near to a client problem, but it will not be exactly ditto of client problem. But yeah, they'll be given a synthetically generated data set, real world problem. And we have a team, structured data, so where people work on tabular data, like which are in the form of CSV, which data is sitting in the table. We have a NLP team, a separate team, NLP. So they work on purely NLP, like a natural language processing data. We have a deep learning computer vision team, so they work on image data set. So yes, that's part of our team. So what we do, if you want to become a data scientist, so you have to start in the same direction what I'm saying. But you have to, once you do iteration one, some of the techniques here, if you want to become if you want to also explore a text data, some other data set, you have to switch your gaze towards text data set. Again, you have to switch your gaze towards image data set. But in the way we do is, the internship will be given to a programmer, to a candidate or to a student. So he'll be in the entire 6 months, he'll be working on only one type of data set. So yeah, so what for you, what I would say is, you learn Python, you learn some of the libraries what I told, choose one algorithm at a time, learn maths behind it, and then apply on real-time data set, evaluate your result, and deploy your model in production, or maybe you show all your results in GitHub, and use some sort of a Docker, use some sort of a Heroku, you use some platforms. The approach is very simple. Structured data, you choose one data set. Structured data as in summary, in data sciences, work on either structured data or text data, or maybe image data. Image data, it could be videos also. So at a high level, they work on these kind of data sets only. Again, there are domains. Some of the approach differ for domain to domain, but this is like a standard template, you can say. So you learn Python, pandas, linear regression, scikit-learn, build a simple model, and then have a notebook. Then in the iteration one itself, you completed one cycle, right? So you learn Python, you learn pandas, you learn linear regression, you applied using scikit-learn, and then you add extra things to the next new notebook or the existing notebook. EDA is nothing but explorative data analysis. Understand the data, understand each and every variable, understand the pattern within a variable. Try to plot using Seaborn. Try to plot using Matplotlib. There are various libraries to do that. And in the same iteration, enhance, add feature engineering, and then so on and so forth. So this is, it's like incrementally you are upgrading yourself. So this is like a choosing one algorithm, but again within there are sub steps. What happens is, if you start with directly, let's say this approach, directly in iteration, you start with Python, pandas, EDA, and then start building feature engineering. Then again, you will not have feature engineering won't come overnight. like you have to improve your analytical skills. You have to improve your thought process to become good in feature engineering. So maybe if the open source data set, if it is a generic data set, then maybe you can easily pick up a feature engineering. But feature engineering itself is a very big topic. So the best approach is build a baseline model, run end to end, and then add EDA, add feature engineering, and so on and so forth. Once you do this, it takes maybe less than a month if you apply in one approach, and then spend time on applying. Maybe you take an iteration one, you take 1 month to complete all of this, and then apply on the real data set, maybe 15 days. And then in iteration 2, you choose different data set. Choose maybe here you learned on structured data. You choose NLP, natural, build a sentiment analysis on text data set. Again, use logistic regression here. But some of the tasks which you learned here, again, if you've taken 1.5 months here, you will take only 15 days to 20 days here. Because some of the learning what you have used here, you again use those learnings here. You don't again start from the scratch. And then switch your gaze towards image data set. So this is the roadmap which we follow at our Genpact, and also at our community, right? So this is easiest approach, and you advantage benefit of this approach is you don't get derailed, you don't get demotivated. So because you work on the data set, you work on the problem, right? You love enjoying, and you each time what you do is you see some sort of improvement in the result. You post your questions, right? So each time you add a new thing, right? So that's the reason it keeps moving towards in the right direction, right? So you don't have to be pushed. So automatically you will get pushed, right? It's like a self-driven. You automatically become a self-driven when you try to learn new things instead of a traditional way where someone is teaching you what exactly. This is like applying, right? So it's like applied roadmap. You're applying whatever you're learning on real-time data set. So that's the reason you don't get bored, or you don't get lost. Again, there are problems. The problem is what we have seen is you'll not know end to end. You all the time you have to do is Google and understand what exactly is. So that's for some people it is an advantage, some people for it is a disadvantage. Okay, if someone says what exactly, maybe if you're doing a linear regression, something comes up doing feature engineering, or something comes up which is there in some other algorithm. Some concept comes up in between of these, which is there in some other algorithm. So maybe for some time you might be distracted, but again you have to come back to what you are doing. So you will not know end to end. You will not become expert end to end. Rather, it's like an agile methodology, like in software development life cycle. There are techniques, right? In waterfall model, where one step has to be completed before you move to next step. This is like agile techniques. What you do is you build a small prototype, you take a feedback, and then add features to it, and you build end to end one life cycle, and you release in sprints, right? 15 days you have a small release. In 1 month you have a larger release, and quarterly you have a very very big release with integration with some other team. It's like an agile technique. So you improve by enhancing. You take the feedback, you ask questions, right? So you improve. Here what happens is, luckily in Genpact, you will have a mentor, right? So whatever you are doing, you will be given a real data scientist who is already has spent long enough time. So you have a mentor to guide you, to motivate you, or to provide you right direction. But when you are doing by yourself, it becomes difficult. But you have to find a mentor. It becomes difficult to go in a direction, because sometimes you might be lost. But believe me, whether you have a mentor or not, this is useful. This technique is being applied, and you don't get lost, and you can become a decent data scientist with application, with project on your portfolio in 3 to 4 months, instead of going in a traditional way. So some of the resources, obviously, for Python. For Python, HackerRank is very good. Tutorials point is very good. I'm sure you all have a profile in HackerRank to do a competitive programming, solve problems there. It will also help you to crack big companies. Because you become a competitive programmer. It will also help you to become a good data scientist. To Python, tutorials point is also very good. Kaggle is a place. I'll show you what exactly I'm talking about. this Python you already know, try to solve problems. Again, you don't have to spend time to become data scientist. You don't have to spend a lot of time on this. Even if you know some of the basic things, what you see here in the elementary level, that's enough to get started. Again, you can solve medium, easy, hard problems, which will help you. Again, you don't have to become, let's say, you don't have to become expert in error handling and exceptions, try catch, all of those things. You don't have to learn classes. Regex is not required. Closures, these are decorators. They are the software engineering. Software engineering. Over a period of time, you can evolve. You can evolve and can improve, add these skills to your learning. But to start with, learn only basics. This is the place. The Kaggle is again a very good platform. So if you see here, Kaggle is if those who don't know the Kaggle, so Kaggle is a Google company. It was it's like a this is for competitive programming, right? So to solve problems, to crack a big companies, right? To improve our problem solving skills. This platform, HackerRank or LeetCode. So this is like a competitive platform for data scientists, right? So here you have competitions, you have real-time projects, you have data set, you have teams, you can discuss, you can collaborate with other folks, you can pair up with other folks, you can learn from them. There are communities, there are various others, there are support. People post. If you are facing any challenges, all you can do is you can post, and then suddenly you get a response because of the community. So even if you see their plan, right, it's like a world Kaggle platform. If you have a Kaggle rank, so there are very hardly people who have a very good rank in Kaggle, right? So you're world-class data scientists, the data scientists who are around the world. So this approach is being derived by, I mean, the approach what you see, this is the same. I'll not say 100% it matches with our approach, but it is almost same. So even if introduction to Python, if you see programming, if you see the programming notebook, Python notebook, it is very, very basics. If you go in detail of this, hello world, getting functionality, boolean, list, tuple, working with except, if you see, this is what it is, and you can do it in few hours. I would say. I think there is also estimated time. It's not showing, but yeah. So it is in one. Yeah, I think 5 hours. Yeah. So it is like in one day you can learn this, and that's enough. And then next, you move on to introduction to machine learning. You move on to pandas, and so on and so forth. So this is again, to become a data scientist, this is one of the best platform, because good part is you get people here to ask questions for the help. You get real-time problems to solve. If you see here, if you go to competitions, there are real-time problems. Active competition, if you see here, these are the real-time problem with, you can pair up with folks, you can learn from them, and you have the real-time data set, and then and you also been rewarded. Again, you don't have to win, but at least if your rank is very good, you can show up that in this will help you in getting good job as well. So these are the real-time projects, and I don't think any other platforms like Kaggle has like what Kaggle has. I don't think any other platforms support, or you find very good data scientists on other platforms. They're very complex problem to solve, and then even if you attempt, you don't have to win. Even if you attempt, but you learn a lot by attempting these problems, and they'll give you steps, and you can learn from the code. And if you open one of the competitions, you can see the people post their code. You also have to post your code, right? People follow you, and you can touch with these guys, and you see the discussions, you see the leaderboards, you can form a team, you can connect with those folks who are part of these competitions. So by doing this, you are active, you are engaged, you're solving a problem rather than learning, right? You're solving a problem, and then um, and then when you really solve a problem, you don't know how time goes, and then you yourself, if you spend some time, maybe 2-3 months, if you see what knowledge you acquired by solving a problem, you don't get that in traditional way of roadmap, in learning traditional way of roadmap. So this is one of the technique. DPhi has a very comprehensive, very very good courses, free courses. You can again learn from them. Again, these courses are taught by industry experts. They are not taught by any guys where they have people very good support from various folks. So you learn in 1 or 2 weeks. Like their introduction to NumPy, Pandas, data analysis. So whatever is required, right? There are short courses, short courses, like 5 weeks. In 5 weeks, you understand end-to-end data science, right? So, and this is free. I'm not promoting DPhi. DPhi, it's a community. But whatever I have seen them, it's like a quick way of getting started. You learn in 5 weeks instead of in one and a half month, and start applying your knowledge on real-time projects like Kaggle. Start applying knowledge on real-time projects like Kaggle. So this is what I just want to say. Okay, so you may ask, okay, yeah, well, you're telling a great story. Yeah, do you have any proof? Yes, there are various folks who has done this. Pratiksha she was intern in Genpact. She moved recently for higher studies to Dublin. We applied. I think she was one among the first batches. The applied roadmap, what you see, she was among the first batch who she was part of Genpact in our team. So this was being applied on the batch where Pratiksha was there, and there were various other folks, and she got a PP full-time offer, and then she used the same approach. Dheeraj, again, this guy, he moved to US, and he was part of a Genpact, and he was intern, he was offered full-time. I cannot take the names who are actually doing now, or who are actually working in Genpact. By policy, I cannot post their name, but these guys were part of Genpact and they left, and you can see their LinkedIn profile. You'll see what you can also approach them. What I'm talking about. There is one more guy. These from our folks, right? From Genpact. There is one more guy called Shehbaz. Mohammad Shehbaz. I'm sure you must be knowing this guy. Is a very famous guy. He's a Kaggle grandmaster. He's again, believe me, I've interacted with him various times. He did not follow. He read the books and he solved the problems. He became a data scientist by solving a problem. He used the similar. I'm not saying 100% ditto what I'm trying to say, but he used the similar approach. He built a simple model, baseline model. He did some EDA. He added feature engineering on top of that. He moved to some other algorithm by improving that. So he did the same way. He's a Kaggle grandmaster, and he works for Data Robot. And yeah, so they're all normal guys. Like they're not from colleges like you guys. So they are very from normal colleges, and then they become very good data scientists. And then their studies are there and their proofs are there on the platforms. These two girls, Dania Huzaifa and Madiha Mahek, they are from the college where I studied from. They're learning. They're learning now, and I'll show you what exactly they're doing. Dania Huzaifa recently just passed out, and Madiha is again a fresher, final year student. And these girls they approached me. They wanted to learn data scientist, and the same approach as part of community work, unlearning and relearning community work. So I've given them the same approach, and on top of that, they added some more things, which I'll show you in a minute. But yeah, so there are various folks who are working. As I told, there are 15 to 20 folks we hire interns every batch, every 6 months, and then so the same techniques being applied. Yeah, again, there are various roles. I'll not spend much time here because we are already running late. So now the industry is focusing towards MLOps. There are various roles: data scientist, deep learning scientist, company ML engineer. Industries focusing more of MLOps. I'll just give a summary. Focus on fundamentals. Ask yourself, whether good or bad. Focus on fundamentals. If you're not good, refresh those skills. Learn by solving real-time problem, by doing Kaggle and all. This is the best technique, I would say. You enjoy. You don't get derailed. You don't get demotivated. You'll be self-driven by solving a problem. Spend time on data cleaning and data preparation. Most of the time, data cleaning and data preparation is what we spend. In the initial phase, you don't have to know that, but the more you go in detail of data cleaning and data preparation, which is like if you are using Python, Pandas is the framework which is being used. Spend time on that. Focus more on the coding, engineering, model deployment, cloud, etc. Instead of focusing on the research. What happens is there are various data scientists. We have, like as I told, 100 hundreds of data scientists, nearly 100 data scientists we have in our team, but they are from different background. But only few of them have a very command on coding, very command on engineering part, very good command on deployment part. Not only our company, most of the companies, they have very good data scientists. Their code is there, which is there in their laptop. Unfortunately, they won't be able to use them. They won't be able to deploy them because of lack in the software engineering or the coding skills. They can present their stories to business, but they can, unless the model is being used. I mean, it won't give a business impact if you don't have a very good coding skills. Learn these skills, learn basics, move on. The industry is moving towards MLOps. MLOps is in the machine learning operations. So to become an MLOps engineer, to become a machine learning engineer, right? So basically applied guy who actually deploying the model, or who actually has a very good. So you need to know all of these things. Focus more rather than focusing on research, rather than focusing on going detail of maths. Yes, you have to know all of these. I'm not denying the fact that you cannot become you cannot become data scientist, a very good data scientist, without knowing all of those. That's a fact. But the problem is there are very good. There are that research is already there, and unfortunately, what is happening is it is sitting in the laptop, it is sitting in the server. And there are challenges data scientists are facing, who are not able to deploy the model because they lack in coding skills, they lack in software engineering skills. The focus more on that. I'm sure college from you guys. So obviously you there is a lot of emphasis on coding, but do coding, do SQL, do model deployment, learn cloud, focus on that. Find a mentor. This is very, very important. How do you get mentor? From Kaggle, from LinkedIn. Approach people like me. I'm as part of community work. I spend time on Saturday and to guide people. We don't charge. I don't charge. There are people who don't charge, and they want to just support the communities, right? Build a digital presence. Have a very good solid LinkedIn. Have a solid GitHub account, Kaggle account. Solid build a profile. So if you have a digital presence, right, you'll get a lot of projects to solve. You get to interact with folks. There are people who are very good data scientists, but I don't know how good is that unless I work with him, right? If you have a very good digital presence, if you have your own LinkedIn profile, or your own profile, or your own personal profile, or a proper GitHub account or LinkedIn, so you get to meet people, right? So people approach you. And they approach you and support them. So right, you support them, and then again your profile will increase. Build a solid digital presence. It was it. So I just wanted to tell few things. Again, we are hiring. So if you are a fresher, so if you are really interested, if you have a good profile, I will not directly take. If you have a decent profile, so please share. Connect with me on LinkedIn. Please share your profile. Show something which you already done. Even if you have done coding and all, show something. If you have a good digital presence, so more than happy to have you as an intern. And then we are a very good team. Those bits also, we have various students from bits and IIT and IITs. Those there are instances where they got offered. They were doing interns. They also had a very offers from big giants, big companies, product-based companies. Yet they stayed working with us because of the kind of the work culture we have. So that's the reason we have internship program. So we evaluate you in various direction. It's not only the learning. There are many other things you learn in 6 months. So we don't not only focus on coding. We also help you with your emotional intelligence. We also give a constructive feedback where you grow as an individual, right? Professional career growth. And the good part about our team is we encourage higher studies. We give you very good recommendation. The profile what you see, the moment fresher joins, we support them, to pursue their dreams. If someone is getting a good company after joining, we support them. If someone is getting a good masters, right, we support them. We give literally a constructive feedback. And there are folks in our team, but for 15 years, 20 years. I'm there with Genpact for almost more than 6 years. So join us. And also follow our community, Unlearning Relearning. It's a small, recent community I started. I have a longer vision. Please support us. If you are interested in towards contributing towards so to any work, please feel free to approach me. So that's all. Before I move to question answers, I would like to show you one more thing, what these girls, Madiha and these girls I talked about, right? So I'd like to tell you a few things. So they are doing something like this, right? So they are learning by asking questions. If you see here, they're asking questions. What exactly straight line is? So it's like a conversation, right? Conversational based learning. So this notebook is created by Dania, and these are students, right? So you can see the interest. What this was created in less than a month, and if you ask them any questions related to linear regression, they are expert, and they know what exactly is needed, right? So only the essential part, what exactly is needed, they did everything from the beginning, and they are expert in integration by asking questions. So this is what I just want to tell. They understood whatever is required, and they built this notebook, and this will be posted on our community. We have our own GitHub, and we are planning the same thing for all the models they are doing right now for logistic regression. So this is like a conversation. You ask questions. What is data science? Okay, data scientist will reply you with what exactly data scientist. What is machine learning? Data scientist will reply you. What is categorical features? Data scientist will reply you what exactly. So this is where by asking questions, right? By asking questions, they are learning, and this is being applied, and this has a good impact. Yeah. So I just wanted to wind up. I think I've taken a lot of time. Yeah. Happy to answer if you have any questions. Can you hear me, guys?
Yeah, so we have a question here that, yeah, I've shown the question on the screen.
Any questions? I'm applying for jobs in last month, but everybody is looking for. See, so Abu Talha, right? So you see, if you already have the skills, um, so first of all, you can first thing is you forward me your CV. We hire folks. We don't look for 2 to 3 years of experience. We hire freshers. As freshers, as in we provide internship. So provided you learned these things, you have to apply. So if you have learned these things, if you have not applied by solving a problem, then there is a problem. So basically you need to have a very good, if you don't have a solid college background, so then it becomes very difficult to get a job for a fresher in data science. But if you have a good profile, I can help you with I can refer you. In our company, we have freshers. There are various companies. Uh, Apart from that, I can literally help you, sit with you, and literally help you how to get jobs as a fresher as part of a community work. So approach me, connect me on LinkedIn, and yeah. So every Saturday, I spend time in doing this work. So I'll be more than happy. Yep. All right. Any other question?
Thank you, sir. So we have another question. There's a relationship between business science.
There's a relation. I didn't understand. Yeah. Data science is all about, for a fresher, what exactly business science is all about. I don't understand. But yeah, to what I understand, I think, yeah, obviously, the data science is you help with the data science, you help grow the business, right? So you take decisions based on the data what you have. So you can say decision science. You immediately could say if the data says something, but business, there are domain experts who says opposite to what exactly data is showing. So it's like a collection of data science results plus SMEs of business in that area is what we call decision science. We take decisions based on these two input. There is a relationship, um, but again, not only data science. but SMEs of that business is what being used in collaboration. Data science results plus input from the SMEs of that business is taken by business users to take decisions. Hope that answered. But if not, please connect me, and I'm happy to get into what exactly you're talking about. Connect me on LinkedIn. We can get into call. Okay, Neither. I think I spend a lot of time. Yeah, obviously Npdl certification is useful. You learn there, but you have to apply using on Kaggle. You have to solve problems on Kaggle, on analytics, Vidya, hackathons. Hackathons basically you have to solve problems. Imagine you learn data structures and algorithm courses from NPTL. Will Google hire you as a software engineer? No, they'll not. You need to solve problems on lead codes using the skill what you acquired from data structures and algorithm courses, right? So you have to solve problems. You have to have a rank in very good rank in lead code. You have to have very good rank in hacker rank to get your profile. Obviously, all these learnings are useful. I'm not saying that they're very good course and designed by top universities, right? IITs and all. So it is very good course. I'm not denying that you will not learn. It is useful, but you have to apply all your learning in real-time projects. Where do you apply? Yeah, Kaggle. Do companies allow just Python language in coding? See, it depends company to company. But if you're going for Google or Microsoft, or they of course do data structures and algorithms. Without that, they don't do that. In our case, also we check basics. We will not check like dynamic programming or something like graph or very complex stuff in to interview a candidate. We do check data structures algorithm, but basic problems of data structures algorithm, if you have solved maybe let's say 100 of 200 lead code problems, that's I'm saying more than enough. Even if you have solved let's say frequently asked questions of data structures algorithms, that's enough to do that. You don't have to go in detail. Yeah. How do you do data science modeling algorithms? Do you use pre-use algorithms? Yeah, we use pre-use algorithms. Nothing is derived. I mean, unless you are a core guy, like maybe in a research, maybe Stanford, Harvard, or Facebook, Meta, or Google, core member of the team, you don't make your own library. So we always use something is already logistic regression is already being implemented by scikit-learn in R in Spark. So we always use we don't use our own. So we always use existing one. However, we spend a lot of time in data preparation. So the data preparation is where it's differ from project to project. Feature engineering differs from project to project. So that is not reused. But most of the we already have a template, our own templates. For instance, which algorithm works best? Logistic regression or disjointry or support vector machine or deep learning models or Spark models. Which algorithm is, or maybe let's say for the time series model, Arima, Arimax, Profit, which model works best? So we already have internal Genpact own templates. What we do is we use them. We spend a lot of time on data preparation, and then we have created a framework, our own framework. So once you have a data, so one click, so we upload our data set, prepared data set, and then we get results. Just click on train model. That's also we get our own results. But which certification is good for entry level data scientists? See, certification. See, again, I'm telling certification and all. It's like there are various certifications, but having a rank in Kaggle is let's say you did a course from data structures algorithm, you did some small course, and will that, I mean, I will not say there are hardly any people who recognize the certification in data science. How many problems you solved is what being recognized. So how do they do? Kaggle rank, let's say Kaggle rank. You have participated in Kaggle and you got a rank from Kaggle. So that is what being used. Certification, there is no much weightage to any of the certificate. I'll not say there will always be learning. You know, whichever the certification you take, obviously there is a lot of learning there, and it is very difficult. Some of the certificates are very difficult, but trust me, for entry level, you need to solve problems. So learn things. If there is a person who has done a very good certification, um, maybe some very good, maybe from IBM, let's say IBM certified data scientist, or EMC have their own certificate, EMC, or Google certified data scientist, let's say Google Cloud said. So you will have some weightage. I'm not saying that, because you go through a various rigorous learning stuff, right? But if you have a applied knowledge using that certificate, whatever you prepared, that gives more weightage. Even if you don't have certificates, but you finished one of the hacker rank, you finished one of the data scientist live competition, maybe let's say you were among top 10 percentile. So then that gives more weightage over any certification, because I know I hire freshers. So I give a damn, I mean, personally, that's my personal view. I always look for a GitHub profile. I always look for Kaggle or any other problems I solve for. I don't look for certificates. I don't look for courses, because courses certificates give a structured way of learning, but in real time, you always have a different things to. They give you a certification, will give course foundation, but in real time, it's totally different. In reality, you always have a different things to work on. Yeah. Someone not from great college to companies impact. Yes, we hire. I told you, right? The profile which I showed, Pratiksha, Dheeraj, we hire. Then what is required in achieving that? You have to have a profile. Your digital presence. Digital presence is you have to have a solid LinkedIn account, good score in Kaggle. You have to justify yourself, why you are fit. So basically, you have to have a good digital presence. There are folks I know. Um, After interacting with them, I came to know that so much. They had a very good, great knowledge. Unfortunately, they were not getting opportunities because they did not have a digital profile, and they did not have a good college educational background. So for them, I sat with them and then helped them in their building their digital profile as part of my community work. As part of community work, they got jobs, and there are many case. Shebaz, Mohammed Shebaz, he works for Data Robot. Data Robot, H2.ai, there are few startups, AI startups, AI big startups. So they successful, I would say, successful startup. They don't hire people based on certification and all. They hire people based on how many problems you solved, how digitally good your profile is. So you need to have a first is have a LinkedIn account, very good LinkedIn account, and GitHub account, very good GitHub account. And again, believe me, nobody develops things from the scratch. You always copy paste, you always copy from some other code and then modify according to your need, your learning, your problem, and then upload that code. Don't copy ditto exactly, but apply on some real-time data set, upload in GitHub, and improve. Over a period, it takes time. You will not get job immediately. It takes maybe 3-4 months time. And connect with people, meet people. How do you meet people? Meetup.coms. There are platforms like meetup.coms. There are many data scientist meetups in Bangalore, in Hyderabad, in across global. So if you just type meetup.com, whichever the area you are in, so you will come to know. You actually get to meet real data scientists when you go and meet meetup.com. I go and present in various works. I get to meet various freshers. So have basically you have to be social. To if you don't have a, I don't have a very good college background, but the people surrounded by me are IITs, NITs. My manager is from IIT. My manager is from Accelerate Jamshedpur. My 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 managers, colleagues, most of them they are from IITs. My juniors are from BITS Pilani. My juniors are from NIITs. So there are only few folks from normal college. Like I am from VTU, Belgaum University, Karnataka. So there are only few folks who are from normal college. The way I got into the team which I'm working on is because I had a very good. If you look at my LinkedIn profile, you come to know what I'm talking about. So I had a very good digital presence. Yeah, yeah. Any other thing? Questions? I think how to connect everything with status. See, once you go and like if you go behind, let's say, let me show you what I'm talking about. Stop sharing screen. Okay, I think I'm not sure. See, if you see here, if you learn about linear regression, right? So this, okay. So if you see here, this is nothing but a derivatives, right? So this you use calculus here, calculus to to find a sorry. I'll just show you something. Like a p-values, they are part of a statistic hypothesis testing. So if you understand by us, this is you are connecting everything here. So you built a model. Now you are trying to understand p-value. What is p-value and how that is being used? So by asking questions, right? What exactly p-value is? How that is p-value is important. So this says p-value is what is p-value? Understand p-value is less than 0.5. So then there is a the relationship between input feature and the output feature, right? Output. So you're trying to predict a sales. If the p-value, so basically p-value is in statistics, and sales, you're trying to forecast the sales or predict sales, and with some input features, right? So is there a relation between these two? For that, you have to understand what exactly p-value is. So so basically you go to understand, okay, what is p-value, what is derived, how it is useful. So how you are connecting? See, one way is to learn and then apply. The second way is so within that itself, within what exactly variance is, you understand variance. Variance, okay, variance. This is how variance works. You understand this. So basically, you need to derivatives, partial derivatives. So to identify the optimize your cost function, right? So cost of actual versus predicted. So you use derivatives. For that, you have to identify slope, use gradient descent, right? To use that. So slope, identifying a slope on a simple line is easy. Change in y dot by change in x, right? So it's very easy. But what if I have a graph which is non-linear, which is like some other functions? So that time, so use derivatives to identify exactly actual or predicted value at a particular point. So use derivatives. So basically, it is like you go in detail, math behind linear regression. You choose one algorithm and connect the dots. So that's how you should plan. But again, it is not that easy. What I'm saying, but it can be easily achievable. So learning on fly is what I can say. So when you're solving a problem, learning on fly, and then understanding what is that, and then how that is related. So open linear regression, understand that linear regression, math behind it, and then see there itself, uh, in the notebook itself, how you can use that. Okay. Okay. This is see. I would suggest, if you already have experience, the data scientist is, if you already have a CA, right? You'll be good at numbers. You'll be good at finance and all. So in my view, this is again my personal view. So becoming a data scientist and competing with freshers are very 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 fast, and you cannot beat them. So if you're already a chartered accountant, you're good at numbers or finance. So in my view, you become an SME of what happens is, in data scientist you need an SME. Data scientist will work with subject matter expert, domain expert of that area, and you will have a project manager, product manager, and you have various other folks. I think if you have experience, you know what exactly I'm talking about. So for you is, you understand the basics, um, You understand the data science basics, understand, apply on some of the basic real-time problems which are related to your area, because you are expert in chartered account, you in the finance and accounting stuff, right? You are very good. Try to solve, see how data science can be helpful. So learn the basics, and then go in your realm, become a mediator between data scientist team and the business team, because you understand the finance and accounts very well. Now you understand the basics of data science, and then connect these two by becoming an expert. Maybe you go in the role of business analyst, maybe you become a manager. I am doing the same thing, but I'm not expert like you in finance. I'm currently, the project which I'm working on is on the financial frauds. So we have preventing a financial frauds. We're building a model. We are working for one of the biggest companies, their UPI division, their financial crimes like transaction monitoring, due diligence, all of those, like UPI, like Paytm or WhatsApp, like you have, right? So all the financial activities which happens, right? So we are building a model for them. So we are interacting with a guy who is expert in finance. But I'm trying to digest all of those. So it's like I'm playing a role. I take the input from finance guys, and I take the input from data scientists, and then they talk to business, share the insights. So become expertise in your area. Go in your area. Don't start from the scratch. Don't leave your area. Becoming a chartered accountant is itself is a big challenge. So because you spend a lot of time, you leverage that experience, and don't become like a data core entry level. Don't look for entry level jobs. Instead, you correlate all your experience, domain experience, and then use that experience to solve problems. It's like a data science. Use this as one of your tools. Your chartered account might be using Excel to solve some problems, right? Use these data science libraries or tools to solve your problems in your area. So don't become a data scientist. Instead, understand and then see how you can be used, and lead a team. Join at companies, join McKinsey or join KPMG, some sort of companies where they'll also have data scientists. That's my suggestion. But again, connect me on LinkedIn. I love to interact with people, so I'm more than happy, and I can help you with many things. It's as for the community work, nothing is chargeable. So everything is free. Okay.
Definitely, sir. Thank you so much for all the knowledge that you've shared with us, and the constant delays that we had. We'd like to apologize for them, but thank you for having such a great presentation for us and all of our juniors. We'd also like to thank DPhi for connecting us with you, and in general for such a great experience for our juniors. With this, we'd like to end our session, and thank you again for such a
Thank you very
wonderful
much.
time, sir.
Thank you.
Thank you, sir.
Thank you, this great team, and also thank you DPhi, thank you Mudit and other folks for having me on. Yeah. Thank you.
Thank you
Bye.
so much, sir. Thank you to all the viewers too.